Hey guys, Darren back again. Today let's talk about video and the types of cables that you might come across when you use your retro consoles. There is a hell of a lot of confusion out there. I mean, so much confusion. People have no idea what they're talking about and they give out bad advice all the time on the internet. I see it daily, I see questions posted daily on Facebook and on forums and all over the place where people just have no idea what they're doing, how they're connecting their console, and the sort of output they're trying and expecting to get. So let's go through it. So let's go through the basics and look at the range of cables that you might come across, and I'll give you a basic understanding of what each cable does and its evolution through time and how things have changed. And then how to use your console on a modern TV. I won't give you any real graphical and video demonstrations today, just more of from a technical perspective, just so you've got more of a grounding of an idea of how this stuff works. So, right back in the early days, the consoles like the Sega Master System and the NES had RF, and RF looks like this one. It came in a switch box like this, or a bit bulkier. Typically had a slider across it that let you switch between the antenna input for your TV signal and your console, and then that would just output to your TV. The one end would connect to the back of your console, just like with that sort of connector, and off you'd go. You'd get some sort of a grainy, scratchy picture and you'd be playing your games. This is the most fun, like rudimentary type of video cable you will get. If you're using this type of connector now in 2016, you're really doing yourself a disservice. You're getting a terrible picture quality, especially on a modern TV. Modern TVs just don't understand this technology anymore. This is analog technology garbage. Don't use it, guys. There's plenty of other options. Let's go through them. So this was RF, radio frequency. It's basically sending all the information down one pin, which is in the center here. The outside's ground. That's a grounding connector. All cables have a grounding, and the signal, like the red, the green, the blue, the brightness, the sync information, how it draws lines, the audio, everything is squeezed all from those sources down into one pin of one pin, travels down the wire and into your TV, and that's just disgusting. So you can imagine that one wire can't possibly carry all that information, get it there cleanly, and then display it at the other end. That's a problem. And also, when the chip itself in the console produces the video signal and it combines it all into that raw RF signal, it just degrades. It's like listening to a gramophone versus a digital audio file. That's the sort of quality difference you're dealing with. It's disgusting. So this stuff, really just throw it in the bin. Then we're on to what's called composite video, and you guys will probably out there, you call this RCA or AV, and that's a little bit incorrect, but I'll explain. So what it actually means, they probably should sit in that sort of orientation. The actual connector itself, the piece of metal and plastic, is an RCA connector. That's like a standard type of connector. In Europe, they also call it a sync or cinch connector. That's just the name of the connector. Don't be confused about the type of video you're getting over this connector. So one of the lessons I'm trying to go over here in this video is physical versus video signal. Very different things. So this is an RCA connector, yes. They were all RCA connectors, and this one, the yellow, typically carries composite video, or as the Americans would say, composite video. Just a different way to pronounce the same thing. Just means to compose multiple signals into one. So the word compose, composite video. Typically again, red, green, blue, brightness, sync, all travel down this one center pin right here. That outside bit of metal, that's all grounding. So once again, you've got one pin transmitting all the information. This one's a little bit better because it separates the audio, left and right audio, and that's also an industry standard. White is left, red is right. So you'll see those two on CD type players and so forth. They're very common. As audio, they're still okay. It's still an analog audio. It's okay. It does the job. It's certainly not the best, but it's okay. But from a video perspective, this is still cramming way too much video down one pin. Red, green, blue, sync, brightness, luminance, all that sort of stuff. One pin, and it's just a mess. You know, you'll often see modern TVs struggling big time to reproduce a composite video signal. A modern TV is a digital device. It's purely digital, and this is analog technology. So it has to do a conversion from analog to digital to work. And inside the TV, the electronics that do that piece of conversion are generally fucking rubbish. And that's why products like the FrameMaster Mini, from Micomsoft, that piece of electronics does that upscaling from analog to digital. And that's what upscale means. It also means to increase the resolution, which we'll get to that in a second. But this is composite video, in my opinion, utterly garbage. If you're using this, you're doing better than RF, but still punch yourself in the face. And just ask yourself, are you getting the best out of your console in 2016? The answer is no if you're using this stuff. It's garbage. If you plug this into an old CRT, it would actually probably look better than your modern LCD or LED TV because of the upscaling. The modern TVs just cannot process this signal. And typically what you'll get over this cable is a video resolution of 240p. So 240 pixels, progressive scan. That's what CRT was basically built upon, that sort of video resolution, standard definition, it's probably called in your area, but it's 240p progressive. We've just moved on so much from that era. They still look cool. The retro games still look great at 240, but you've got to process them a little bit different and upscale them to a digital high resolution to really get the best out of them. So anyway, look, that one's for a Neo Geo, Neo AV. I've got a little tag there. Not the best. Throw it aside. The next one is S-Video. So this was really common in America, also here in Australia and Europe, but a little bit less so. We still had it, but you probably never used it really. So this is just a double-ended one, just for demonstration. But you'd have your console connector on one end and this on the other to go to your TV. And this is better than the last one because I'll zoom in there. Sorry, I should have zoomed in earlier, shouldn't I? We've got more to look at though now. So we've got more pins. So this is one step better than composite video RCA connectors, which we just showed, because it's got more pins. The outside shielding is ground, and actually two more of those pins are actually also ground, but two of them, let's call it the data. So the actual video signal travels over two of the pins, and it separates, in a nutshell, it'll separate the brightness and the luminous and the signal into two halves. So the signal gets separated into two halves, traveling down separate wires. So when you start to separate signals, you maintain quality, and that's the whole purpose. So S-Video is one step higher quality than composite video. Something I should make clear is this only carries video. The audio would still need to be run separately like that on your standard sort of audio connectors. So composite video ran down one, S-Video runs down two pins in a nutshell, and the audio is carried separately. So it's a better cable to separate the signal out. So it's not a bad option. It definitely gives you much more vibrant, clearer colors and less distortion than composite, but still, it's not the best. But if your TV has an S-Video port and your console outputs S-Video, or you can mod it for S-Video, it's not bad. You could do a lot worse. You could do one of these pieces of shit over here. So we'll put that on the pile, but something to think about, but I wouldn't rush into playing with S-Video. The next one is component video, and this is still, for an analog format, this is still quite good. Yeah, conditions apply. It's good, but it could be better. In a nutshell, it separates the signal one step further. We've now got three connectors passing the video signal, and then the audio off here separately, left and right, just separate. So the video, instead of the composite having everything down one yellow center pin over here, we've now got the same video split into 3 pins. From the outside connectors, red, green, and blue, you think it's red, green, and blue, but it's actually not. It's actually quite technical video breakdown across the 3 pins. I won't get into that. It's hard to explain on a video like this, and it's not really, you don't really need to know about it. Unless you're an engineer and you want to get into this stuff and read about it, go ahead and read about it. But it's basically a mathematical derivative of each one. So one's minus the other one to get to the other one, and so forth. It ends up with a nice, clean, pretty clean video signal actually. Component was quite good. It's one of the pinnacle connector standards of the analog era, and because it separated them nicely, and it still holds up quite well today. Some consoles like the PS2, the Xbox original, and a few others use component, and they'll output a higher resolution over component. That's their highest standard. They also support composite, but when you tell them that you're using component cables, they'll go perhaps to 480i, which is 480 pixels interlacing. It alternates the frames, or 480p progressive. So yeah, sometimes you get a high resolution over component, and that's a really good option. It's not bad at all. So consoles like, the Xbox and PS2, I'll still run them over component because it's the best we can really get at this stage of the game without doing, custom mods internally. So pretty good, the old component. If you've got it, your TV supports it, which they generally all do still. It's really not too bad, but unfortunately most of the retro consoles didn't output component natively, so you'd have to open them up and modify them to do so. Next is my personal favorite for retro is RGB SCART. So not to be confused again with physical versus video signal. This physical piece of plastic and metal is a SCART connector. In Japan they also have one called JP21, very, very similar, 21 pins, but a different standard. We're talking about the European one. If you're going to get into SCART connectors, I would highly recommend you get into European SCART standard. Don't get the Japanese JP21. It's just not a path worth going down. These are just much more available and cheaper and just more prevalent on the internet to buy. So this particular one is from a company called retrogamingcables.co.uk. I personally like their products. I think they're very good. You can order them in different specifications such as C-Sync, and you can order the style of and the spec cable that you want off their website, and obviously you can get it to suit your console. This one is a Neo Geo AES. So why is RGB SCART better than these formats over here? Well, it separates the video into more pins. There's a lot of ground pins actually here. Without getting too technical, yes, we've got separate pure red, pure green, pure blue, and a return ground pin for each of those. So that's 6 pins already. 6, yes, I can count. So red plus ground, green plus ground, blue plus ground, audio left and right plus ground, grounding shield around here. This whole outside is ground. It also carries composite video. So yes, this sort of old composite over here, this whole pin here is equivalent to, it's actually that top pin up there, I believe, from memory, that top pin 21 or pin 20, I think it is. That one up there. So there's a lot going on in the old SCART connector. And I see discussions on the internet. Someone will say, will I get a better video quality and picture format if I use SCART? And the short answer from rookies is yes. But what they don't get is you can get a SCART running composite, and it's just the same as doing that. You've got to get RGB coming out of your console to really make the most of a SCART connector. So when you talk about SCART, we're talking about a physical connector. You've got to then be specific and talk about RGB running over SCART or composite running over SCART. This will actually even support S-Video. So you see what I mean? It's a very universal connector. The Europeans jumped on board. The back of the TV would have a socket to match that. And it's just a fantastic analog format. It is really good for retro gaming. So most of the consoles of the era all outputted RGB natively. You know, off the top of my head, Master System, Mega Drive, obviously the Genesis, the Neo Geo, the Super Nintendo, etc., etc. The N64 can do it with a small mod, and you know, you go through the whole range of consoles. They can all do RGB quite easily, and in my opinion, the old SCART connector is the way to do it. Yeah, I got this labeled up. This particular one, yeah, from Retro Gaming Cables. He does a really good job actually. I think his name is Robert. Made in Great Britain. You know, you can buy cheaper ones, and I actually started making my own SCART cables and selling them myself, and they were okay, but I really just couldn't get the quality that I wanted, and I stopped doing that, and I started recommending Retro Gaming Cable to my clients because I just think he just makes great cables. So jump on board, guys. It's time to join the RGB SCART generation and get your consoles looking the best. And just a quick demonstration of the other end of that cable for the Neo Geo. It's an 8-pin DIN C-type, goes in a big capital C, you can see there. This particular one I ordered has a breakout for audio, so you can use this on the headphone jack of the console and get stereo audio out instead of the mono audio that would come out of the socket. So you're getting your audio feed in here, feeds in, and then goes down the cable to your SCART connector. So you can order cool things like that from these guys, so that's a bonus as well. And then quickly on to the final couple of cables. You know, this one is a VGA cable. It's also analog. You'll see this on computers very commonly on the back of your monitor. Well, you probably won't anymore, you used to. It's also RGB. It just has a different way of syncing the video. It's like a horizontal, vertical sort of sync, different system. There's a different technical standard of how this works, but in a nutshell, they're really not too dissimilar, these formats. Really, really similar. And yes, you can convert between them. So you'll see this on the Dreamcast. The Dreamcast runs VGA. I think it was the very first console ever to run VGA, which is a really good format. It runs up to 480i. Sorry, it runs up to 480p, I believe. And picture coming out, you know, video coming out of a Dreamcast always looks phenomenal. I love it. It's probably my favorite console. Haven't quite decided. I am very partial to the old Master System, even quite partial to the old Super NES. So I don't know. I don't really want to make a decision. I like them all. So VGA, just for interest, yeah, you'll see it on the Dreamcast, but not many other consoles. Then pretty much the line was drawn. They stopped making analog and they moved to digital. And this is a DVI connector. You'll also see this on your monitor. And it's a digital system. And then we obviously move on to HDMI, which is another digital connector. And you know, there's also other digital connectors which I haven't got in front of me today. But the main difference, what you need to understand, is the analog connectors literally put voltage down the wire. It's like an alternating voltage wave that it was produced by the chips in the console, pumps down the wires literally, and you cross your fingers, it got to the other end. Voltage literally going down the wire, up and down, up and down, up and down, like changing levels. And what happens when you send voltage down a wire is you get inductance. You get another wire running next to it. So for example, you know, there's multiple wires in here. One wire is carrying the red information and it's got a, you know, let's say 2 volts running across it. If you don't have a ground wire right next to that, or you don't have a return path for that signal, some of that voltage will produce magnetism, which will bleed into the green wire, and so forth. And that's where you start getting messy pictures. And low quality cables don't have enough grounding and shielding inside them to prevent that happening. So the signals and the voltage produces electromagnetic radiation basically, and it induces and jumps across wires, and you'll often get hum in the audio because it's picking up red or green or blue video information in the audio wires. That's what the hum is. The only way to fix that is to buy high quality. I learned that the hard way. Don't do the same thing I did. Don't try and cheap out onto AliExpress or eBay. It's just all garbage. Go to a proper supplier. There's a couple of good sellers. I won't go through the list here on the video. I'll probably post a link to that below, but just get high quality, guys. So analog was voltage modulation, basically, around the 2 volts sort of level. And then digital, in a nutshell, how it's different, all these connectors, they can obviously pass a lot more information down the wire per second. And when you can start doing that, you can run higher resolutions. You can run, not just 240p and 480p. You can run obviously right up to 1080p and even higher these days into the 4K TV sort of range. And how they do that is it's basically just ones and zeros. So each pin will do a slightly different thing. Some are redundant, some back each other up, and some are fault tolerant. But it's basically firing ones and zeros, changing in rapid sequence in binary down the wire, and at the other end, a chip will decode that code, the binary code, back into the video signal. It goes through the chip, and it'll display it on your TV. So you can just pump a lot more video down the wire. There's also less interference from crosstalk and the things I was talking about before, because they've optimized the way the signals are sent down the wire. So it still is a voltage, but it's just optimized to be high speed, low interference, and has all sorts of correction and detection built into the protocol to prevent problems. So yeah, you get much higher resolutions, but yeah, fundamental difference, and the line is drawn basically here: analog, digital, and trying to plug in a piece of shit analog composite video signal into a modern TV, which is digital. The TV has to do the analog to digital conversion, and it's just rubbish. So that's why your picture's always going to look crap. There's really not much you can do about that until you go down the path of upscalers, and then an upscaler will do that job for you. It'll do analog to digital, but it can only process as good as the video signal is coming in. So if you feed it composite video and you expect crystal clear digital at the other end at 1080p, you're kidding yourself, because this is shit, and this is just a digital connector. So it's going to just pass shit video in, shit video out in a digital format. That's not really what you want. You've got to start with a high quality, or this high quality RGB, pure red, pure green, pure blue signal with separate sync signals coming in as clean as possible from the analog world. Start high quality, then you do your conversion, and then your output will be digital, of course, but it'll be at a nice high quality. So I can't stress that enough, guys. Use high quality cables, use a high quality upscaler, do the job once, do it right, and you won't be disappointed. You'll be blown away the difference that it actually makes. It's hard to demonstrate, and there are other videos online that'll go through that difference. Adam Korelic does a really good job of demonstrating videos, and so do the My Life in Gaming guys. They do phenomenal videos explaining this at more of a visual level. They'll actually show you the captured footage. I don't do that sort of stuff at the moment. I just stick to the technical stuff. It's what I enjoy more. But yeah, yell out if you want to see that kind of stuff, and I can look into it. But for today, guys, that's it. I hope you understand cables, and you can make sense of this mess when you look at your stuff. If there's anything to take away, this goes in the bin. This goes in the bin. Everything else is okay. All right, guys. See you next time.